Assalamu alaikum dear students. Welcome to the lecture of the classical mechanics. In this we will discuss the solution for the problem number 7.28, which says the particle of mass m is attracted to a force center with a force of magnitude k square over r. Mean particle is attracted, so we have to use plane polar coordinates and find Hamilton's equation of motion. The very first thing is that a particle is attracted, so F will be equal to minus k r power minus 2. This minus sign shows that particle is attracted, because in the question it is stated that the particle is attracted, and then from this force we have to find the kinetic energy and potential energy, and from there we will find the Lagrangian. So F is minus k over r square r minus k r power minus 2. This minus down there show that attraction, just because this shows the particle is attracted, so minus is just for attraction. So we can find, we know that F is equal to minus du over dr, and u will be equal to minus f dot dr. So we can put that force at this equation and integrate this. That will lead u is equal to minus k r power minus 1. And you know that particle is in 2 dimensions, so its kinetic energy will be equal to T is equal to m over 2 r dot square plus r square and theta dot square. Very earlier calculation we have done that T is equal to m over 2 r dot square plus r square theta dot square, and potential energy is this. So we put this in the Lagrange equation, m over 2 r dot square plus r square theta dot square minus potential energy. So this minus will get positive and it will be equal to k over r. Then we have to find the generalized momentum PR, which will be equal to partial L over partial R dot. We have L, we can put it and find the PR. And similarly, from this expression we can find the R dot, which will be equal to PR over M, and generalized momentum P theta, which will be equal to partial L over partial theta dot. Theta dot, this will give this equation, and theta dot will be equal to P theta over M R square. You can rearrange this equation just for theta dot and R dot. This will now we have to find the Hamilton equation of motion. Since the coordinate transformation are independent of t and the potential energy is velocity independent, Hamiltonian is the total energy. So when the coordinate transformation are independent of t means coordinate does not depend upon t, it means the total energy will remain conserved, and the potential energy, or if potential energy is velocity independent, that our total energy will remain conserved. Hamiltonian will be equal to total energy in this case. So Hamiltonian is equal to T plus U. We have kinetic energy plus potential energy. This is the total Hamiltonian. We have found R dot in the previous expression and theta dot. Just plug value of R dot and theta dot in this expression and rearrange this equation. It will be equal to PR square over 2m plus P theta square over 2mr square minus K over R. Now Hamilton's equation, you know that once we found Hamiltonian, then we can find the Hamilton equation. So R dot will be equal to partial H over partial P, and theta dot is equal to partial H over partial P theta. Similarly, PR dot will be equal to minus partial H over partial R, and P theta dot will be equal to minus partial H over partial theta. We have value of Hamiltonians. We can just plug in this equation and take its derivative correspondingly. This will give the following values. I think these were the requirements in the question, and we have solved it. In the next question, I think this is relevant to the problem number 7.15, and it will be good if I record it in the next lecture. So I will stop at this point and discuss separately in this question, because it will be necessary to code this equation problem 7.15.